Okay, so today I want to start talking about sound power. This is the same power that we were talking about before. It is energy per unit time. It is going to be watts, which are defined as joules per second. And remember, sound power is the power produced by the instrument itself. It does not depend on how far away you are. This is another formula that you should know. The relationship between intensity and pressure. In other words, intensity goes up by the square of the pressure. As the pressure becomes, so if the pressure is 1 time, intensity is 1 time. If the pressure becomes 2 times, intensity becomes 4 times. If the pressure becomes 3 times, intensity will become 9 times. Where rho is just the density of air and v is the speed of sound. So at any given time, the density of air and the speed of sound will not change. Do you remember speed of sound can only change with temperature? So, but the temperature doesn't vary too much. So you can almost say that intensity is proportional to pressure. So again, this is a formula for SPL. 20 log of P over P0. What is so fascinating about this is that the smallest pressure that we know of is 2 times 10 to the minus 5 Pascal, but the atmospheric pressure is 1.1 times 10 to the plus 5 Pascals. So that means a detectable pressure is 2 times 10 to the minus 10 times smaller than atmospheric pressure. That's how much human ears can hear. Fascinating. Such a tiny, tiny, tiny pressure. But humans generally don't like numbers that small. And so what's our solution? We have come up with another term called SPL. And remember, decibel is just a scale we are using in order to make life easy for us. And that's how we've defined it. And so this is the equation we did last time. And that's what you did in your lab, correct? You had the sound level meters and you placed them at different spots. What did you realize when you moved them further away? Did the value go up or did the value go down? As you moved it away, it went down, right? So that means that the intensity of sound varies as the distance. The further away you are, the less intense the sound is. And that's what it's saying here. Okay, so what's the relationship? The basic relationship between sound pressure and sound pressure level is given here. Look at this number. What is that number? How many zeros does it have? 1, 2, 3, 1, 2, 3. So it's 100 million. Would you like to write this number over and over again? Would you rather write 130? And that's why we came up with the decibel scale. So a decibel scale, this would be 20 log of P over P0, right? So this is the P, and this is the dB. And that gives me my dB. So instead of writing 100 million or 100 million, 200,000, 50, blah, 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 3, you could just write 129. Which one would you prefer writing, right? 109,045,559 or 129. Got it? And that's the reason why we came up with the decibel scale. It's just to make things easier for us to understand. Like, for example, is 130 bigger or 128 bigger? It's easy, right? Right away. But if I say 9,945,554 versus 9,945, blah, 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 right? It's harder to say it and it's harder to understand. That's why we have the scale. So the threshold of hearing, if you look at this point right here, the threshold of hearing in the decibel scale is 0, easy. In the sound pressure scale is 20. Whereas just a light rustling of leaves is about 20 on this scale, whereas 100 and, I don't know, like maybe 130. And note what scale this is. This goes from 20 to 100 to 1,000 to 10,000 to 100,000. And that automatically is a log scale. So it makes sense for us to convert it into the decibel scale. So even though sound power and sound pressure remain, they sound the same thing, but be very, very careful. Sound pressure level depends on the distance, the position, and the source. Whereas sound power level is just the power that the source is creating, just the noise the source is creating.